Good evening, and welcome back to Boring Science for Sleep. Tonight, we're going to drift somewhere very unusual. Not to a bright galaxy full of stars, not to a glowing nebula, and not even to the crowded neighborhoods of the cosmos where thousands of galaxies swirl together. Instead, we're going somewhere quieter, much quieter. Tonight, we're traveling to the emptiest places in the universe. Before we begin, though, I'd love to know something. Where in the world are you listening from tonight? And what time is it there? Some of you might be watching just before bed. Others may already be under blankets with the lights dimmed. And somewhere on Earth right now, someone else is just beginning their night beneath the same sky. So if you feel like it, let us know in the comments. Where are you watching from? And what time is it where you are? Then settle in, relax, and let your mind drift gently into space. When most of us imagine the universe, we tend to picture it as something full of stars, full of glowing galaxies, full of swirling clouds of gas and dust. And in a way, that picture is true. The night sky above us sparkles with thousands of stars, and powerful telescopes reveal billions of galaxies scattered throughout the cosmos. But there is something strange about the universe that astronomers discovered only relatively recently. When they began mapping the positions of galaxies across vast distances, they noticed something unexpected. The galaxies were not spread evenly through space. Instead, they gathered together. Clusters of galaxies formed enormous chains and filaments stretching across the universe. These filaments connected massive galaxy clusters, creating a vast cosmic network. Astronomers sometimes call it the cosmic web, a structure so enormous that it stretches across billions of light years. But between those glowing threads of galaxies, something else appeared. Something very different. Immense regions where almost nothing exists at all. Vast expanses of space where galaxies are incredibly rare. Places where the universe becomes almost empty. These regions are known as cosmic voids, and they are not small. Some cosmic voids span hundreds of millions of light years across. Distances so vast that light itself takes millions of years just to cross them. Inside these voids, the universe becomes strangely quiet. No bright galaxy clusters. No crowded cosmic neighborhoods. Just enormous volumes of dark space. If you could travel into the center of one of these cosmic voids, the sky around you would look very different from the one we see on Earth. Here on Earth, our night sky is rich with stars, but in the deep center of a cosmic void, galaxies would be incredibly distant. The nearest galaxy might lie tens of millions of light years away. The sky might appear darker than anything we have ever seen. A vast, silent ocean of space, with only faint islands of light scattered along the horizon of the universe. In some ways, cosmic voids are like the great oceans of the cosmos. Imagine the galaxies as islands and continents. Between them stretch enormous cosmic seas, empty, dark, and unimaginably vast. Most of the universe is not made of galaxies. Most of it is this quiet emptiness. And yet these cosmic voids are not meaningless gaps. They are part of the grand architecture of the universe. The empty spaces that shape the cosmic web, the quiet regions that allow galaxies to gather along glowing filaments. Without voids, the large-scale structure of the universe would look completely different. The emptiness itself is part of the design. Tonight, we will slowly explore 100 sleepy facts about cosmic voids. We will drift through the vast cosmic web, visit the largest empty regions ever discovered. Imagine what it might feel like to travel through these silent spaces between galaxies, and reflect on what these enormous voids reveal about the nature of the universe. So dim the lights, get comfortable, and allow your thoughts to float gently into the quietest places in existence, far beyond our galaxy. beyond the bright clusters of stars, there are regions where the universe grows incredibly still, vast oceans of darkness between the islands of galaxies, the cosmic voids, and tonight we're going to drift slowly through them together. As we gently continue our journey through the universe tonight, let us begin with a quiet realization about the cosmos, one that took astronomers many years to fully understand. At first glance, it might seem reasonable to imagine that the universe is filled evenly with galaxies. After all, when we look up at the night sky, stars appear scattered everywhere. And when telescopes peer into the deep cosmos, they reveal countless galaxies, spiral galaxies, elliptical galaxies, glowing clusters of stars stretching out in every direction. It would be natural to assume that these galaxies are sprinkled through space like grains of sand across an endless beach. But the universe does not arrange itself so simply. When astronomers began carefully mapping the positions of galaxies across the sky, something surprising began to emerge. Galaxies were not spread smoothly throughout space. Instead, they gathered together. Some regions of the universe contained large numbers of galaxies clustered closely together. Other regions appeared strangely empty. At first, this pattern was subtle, but as telescopes improved and surveys expanded, the pattern became clearer. Galaxies were forming large cosmic structures, connected together in vast formations stretching across unimaginable distances. One of the most common structures in the universe is known as a galaxy cluster. A galaxy cluster is exactly what its name suggests, a large group of galaxies bound together by gravity. Instead of drifting alone through space, many galaxies exist within these gravitational communities. Some clusters contain a few dozen galaxies, others contain hundreds. The largest clusters may contain thousands of galaxies moving slowly around a shared center of gravity. From afar, these clusters appear like glowing cities of light scattered through the darkness of space. Our own galaxy, the Milky Way, is not alone either. It belongs to a small group of galaxies called the Local Group. Within this group, the Milky Way is accompanied by several neighboring galaxies, including the large spiral galaxy Andromeda and dozens of smaller dwarf galaxies. These galaxies interact through gravity, slowly orbiting one another across millions of years. Even this modest group represents a small example of the way galaxies tend to gather together, rather than remain isolated. But clusters themselves are only the beginning. When astronomers widened their view and began mapping galaxies across enormous regions of the universe, they noticed that clusters were also connected to one another. Clusters form chains. Long bridges of galaxies stretched between them. These bridges are known as cosmic filaments. Imagine strands of glowing threads stretching across the darkness of space. Along these threads, galaxies form long rivers of light. Thousands of galaxies may lie along a single filament, all slowly moving through the gravitational pull of the surrounding structure. When seen on the largest scales, these filaments form a gigantic network. Clusters of galaxies sit at the intersections. Filaments connect them across vast distances, and between the filaments, enormous empty regions appear. Astronomers often describe this structure as the cosmic web, because when the positions of galaxies are mapped in 3 dimensions, the universe begins to resemble a vast web or foam-like pattern. Bright threads of galaxies woven across an immense cosmic tapestry. Yet what makes this structure so fascinating is not only the galaxies themselves, it is also the spaces between them. Between the glowing filaments lie regions where galaxies become incredibly rare, places where the universe grows quiet. These regions are the cosmic voids we began discussing earlier. But to understand those voids, we must first appreciate the structure surrounding them, because voids are not random holes. They are the natural result of the way matter gathered together during the early history of the universe. Long ago, shortly after the universe began expanding, matter was distributed almost evenly throughout space. But not perfectly evenly. tiny differences in density existed, slightly denser regions and slightly emptier ones. Over billions of years, gravity slowly amplified these tiny differences. Regions with slightly more matter attracted additional matter. Galaxies formed. Clusters grew larger. Filaments stretched between them. Meanwhile, regions with less matter gradually lost what little material they had. Matter drifted away toward the growing clusters and filaments, leaving behind vast areas of increasingly empty space. The result is the large-scale structure we see today. A universe shaped not like a uniform cloud, but like a vast network of matter. Galaxies gathering along filaments, clusters forming at their intersections, and enormous voids stretching between them. In some ways, it resembles the structure of foam, or bubbles in a vast cosmic sea. The galaxies trace the edges. The voids occupy the interior spaces. From our position inside the Milky Way, we are already part of this structure. Our galaxy lies along one of these cosmic filaments. Nearby clusters and galaxies form part of the same network of matter. And far beyond our local region, the cosmic web stretches across billions of light years. A structure so vast that even light takes immense spans of time to cross it. So when we look up into the night sky and see stars scattered above us, we are witnessing only a tiny piece of this enormous cosmic pattern. Beyond the stars visible to our eyes lie galaxies. Beyond those galaxies lie clusters. Beyond those clusters lie filaments connecting vast regions of the universe. And between them all lie the quiet spaces we are slowly approaching. The cosmic voids, places where the universe becomes almost unimaginably empty. In the next part of our journey tonight, we will explore how astronomers first began to notice these enormous empty regions and how mapping the universe revealed the hidden architecture of the cosmos itself. As we continue drifting gently through the structure of the universe tonight, we arrive at a fascinating moment in the history of astronomy. The moment when scientists first began to realize that the universe was not simply filled with galaxies, but also with enormous regions of emptiness. For much of human history, the universe appeared simple. When we looked up at the night sky with our eyes alone, the stars seemed scattered randomly across the heavens. Ancient observers could see patterns among those stars, constellations, and familiar shapes. But beyond that, the sky seemed like a vast field of lights. Even when early telescopes revealed distant galaxies, astronomers initially assumed that these galaxies were distributed fairly evenly through space. It seemed reasonable to imagine the cosmos as a kind of grand star field. But as technology improved during the 20th century, astronomers began to ask deeper questions. Where exactly are galaxies located in space? And how are they arranged across the universe? To answer these questions, scientists began conducting galaxy surveys. A galaxy survey is essentially a detailed map of the universe. Astronomers observe thousands or even millions of galaxies and measure their positions and distances. By combining these measurements, they can reconstruct a three-dimensional map showing where galaxies are located across vast cosmic volumes. In the early days of astronomy, this task was extremely difficult. Galaxies are incredibly distant objects. Even the closest ones lie millions of light years away. But as telescopes became more powerful and photographic techniques improved, astronomers gradually began collecting the data needed to build these maps. One of the earliest pioneers in mapping the distribution of galaxies was the American astronomer Harlow Shapley in the early 20th century. Shapley studied large clusters of galaxies and noticed that they were not evenly scattered across the sky. Instead, they appeared to form large groups and concentrations. This observation hinted that the universe might possess a larger structure beyond individual galaxies. But at that time, the available data was still limited. The true shape of the universe remained largely hidden. Decades later, new observations began revealing more of the cosmic picture. In the 1970s, astronomers started conducting more systematic surveys of galaxy positions. They measured not only where galaxies appeared on the sky, but also their redshift, a measure of how fast galaxies are moving away from us due to the expansion of the universe. Redshift allowed astronomers to estimate the distance to each galaxy. By combining position and distance measurements, scientists could begin mapping the universe in 3 dimensions. For the first time, the large-scale structure of the cosmos began to emerge, and what they discovered was unexpected. When the data was plotted on these early cosmic maps, galaxies did not appear randomly scattered. Instead, they seemed to form long chains and clusters. Even more surprising, between these chains of galaxies were large empty spaces, regions where very few galaxies appeared at all. At first, astronomers wondered whether these gaps might simply be caused by incomplete data. Perhaps the surveys had not yet observed enough galaxies. But as the surveys expanded and more galaxies were mapped, the pattern remained. The empty regions were real. They were enormous, and they were everywhere. One of the most famous early visualizations of this structure came from a study conducted in 1986 by astronomers Margaret Geller and John Huchra. They created a map of thousands of galaxies within a slice of the nearby universe. When they plotted the galaxies on their map, the result looked astonishing. Instead of filling space evenly, the galaxies traced delicate, interconnected patterns. Clusters linked by thin filaments, curving arcs of galaxies forming enormous walls, and between those structures, vast, empty regions. The pattern resembled something surprisingly familiar. It looked like soap bubbles, or foam. Galaxies formed the thin edges of bubbles, while the interior spaces remained mostly empty. This discovery gave rise to one of the most poetic descriptions of the universe's structure. Astronomers began calling it the cosmic foam, or cosmic web. Imagine a gigantic 3-dimensional foam stretching across the universe. The thin edges of each bubble contain galaxies. The interior spaces are mostly empty. Those empty spaces are what we now call cosmic voids. Some voids span tens of millions of light years. Others are even larger. They are among the largest structures known in the universe. Not because they contain so much matter, but because they contain so little. One of the first cosmic voids to attract major attention was discovered in the early 1980s. It became known as the Quietest void. This enormous region lies roughly 700 million light-years away in the direction of the constellation Botes. The Quietest void is so vast that it measures roughly 250 million light-years across. To put that into perspective, our entire Milky Way galaxy is only about 100,000 light-years wide. The Quietest void is therefore more than 2,000 times larger than our galaxy. Yet inside that enormous volume of space, astronomers have found very few galaxies. Only a handful appear scattered within its vast interior. For a region so immense, the emptiness is astonishing. When the Quietest void was first discovered, some astronomers jokingly referred to it as the Great Nothing. The nickname reflected both its enormous size and its remarkable lack of galaxies. Yet despite its emptiness, the Quietest void quickly became an important subject of study. By examining the edges of the void, astronomers could better understand how galaxies gather along filaments and clusters. The void itself helped reveal the large-scale architecture of the universe. Over time, additional galaxy surveys confirmed that the Quietest void was not unique. In fact, the universe appears to contain many cosmic voids. Some are small, others are enormous. Together, they form a network of empty regions between the filaments and clusters of galaxies. These surveys eventually expanded to include millions of galaxies. Projects like the Sloan Digital Sky Survey produce detailed three-dimensional maps of the universe across billions of light years. When astronomers examined these maps, the cosmic web became unmistakable. Galaxies tracing glowing filaments, clusters forming massive intersections, and between them all, vast cosmic voids stretching across unimaginable distances. Today, astronomers understand that cosmic voids are a natural part of how the universe evolved. They are not mysterious gaps or missing matter. Instead, they formed gradually over billions of years as gravity pulled matter toward denser regions. As matter flowed toward galaxy clusters and filaments, the emptier regions became even emptier, like valleys deepening between rising mountain ridges. The result is the extraordinary structure we see today. A universe woven from filaments of galaxies surrounding enormous cosmic voids. And in many ways, these voids are just as important as the galaxies themselves. Without them, the universe would look completely different. The cosmic web, the great structure of the universe, would not exist. Voids help define the shape of the cosmos. They reveal how matter moved and gathered over billions of years. They allow astronomers to test theories about dark matter, gravity, and the expansion of space. Even emptiness has a story to tell. So as we drift further into our exploration tonight, remember that the universe is not simply a collection of galaxies scattered through space. It is a grand structure, a cosmic web stretching across billions of light years, clusters shining like cities of stars, filaments forming luminous bridges between them. And between those glowing threads lie the great, silent oceans of the cosmos, the cosmic voids. In the next part of our journey, we will take a closer look at what exactly defines a cosmic void and how astronomers measure and understand these enormous empty regions of space. As we continue drifting deeper into the quiet architecture of the universe tonight, we arrive at a simple but fascinating question. What exactly is a cosmic void? The name itself sounds mysterious. It suggests an emptiness so complete that nothing exists within it. But like many ideas in astronomy, the reality is a little more subtle and perhaps even more beautiful. A cosmic void is not a perfect vacuum. It is not a region where absolutely nothing exists. Instead, a cosmic void is an enormous region of space where galaxies are extremely rare. Compared with the crowded filaments and clusters of the cosmic web, voids contain very little matter. They are the quiet spaces between the great structures of the universe. To understand this more clearly, imagine looking down at a giant three-dimensional map of the cosmos. Across that map, you would see long glowing strands of galaxies. These strands form the filaments of the cosmic web. Where several filaments meet, large clusters of galaxies gather together. These clusters shine brightly with the combined light of hundreds or thousands of galaxies. But between those filaments and clusters lie enormous gaps, regions where the density of galaxies drops dramatically. Those regions are the cosmic voids. They are the dark spaces between the luminous threads of the universe. What makes cosmic voids so remarkable is their immense size. Even the smallest voids are enormous compared to familiar cosmic structures. Some voids measure tens of millions of light years across. Others are far larger. The largest known voids can stretch for hundreds of millions of light years from one side to the other. To appreciate how vast this truly is, consider the size of our own galaxy. The Milky Way spans about 100,000 light years in diameter. A large cosmic void can therefore be thousands of times wider than our entire galaxy. Inside such a region, you could travel for millions of years at the speed of light and still remain within the same enormous empty space. Within these voids, galaxies are not completely absent. A few isolated galaxies can still be found drifting through the darkness, but they are incredibly rare. While a dense galaxy cluster may contain thousands of galaxies packed together, a cosmic void might contain only a handful scattered across vast distances. The difference is dramatic. It is like comparing a crowded city to a remote desert. In the city, lights fill every street. In the desert, you may travel for miles before seeing another person. Cosmic voids are the deserts of the universe. Quiet, open, and almost empty. Astronomers sometimes describe cosmic voids as regions with very low matter density. In the crowded filaments of the cosmic web, matter, both visible matter and dark matter, collects together through gravity. But inside voids, the density of matter is far lower than the cosmic average. Over billions of years, gravity has slowly pulled matter away from these regions and toward the filaments and clusters surrounding them. The result is a universe where matter flows outward from voids and gathers along the edges. In this way, voids are not simply empty spaces. They are dynamic regions shaped by the movement of matter over cosmic time. The boundaries of cosmic voids are defined by the filaments of the cosmic web. These filaments act like the walls of enormous bubbles. Along these walls, galaxies gather in long chains and clusters. Inside the bubble, the space remains mostly empty. When astronomers map the universe in 3 dimensions, this pattern becomes strikingly clear. The galaxies trace a delicate network of glowing threads, and between those threads lie vast hollow spaces. Together, they form the extraordinary architecture of the cosmic web. Another remarkable feature of cosmic voids is their smoothness. Because they contain so little matter, there are fewer gravitational disturbances inside them. In galaxy clusters, gravity pulls galaxies in many directions. Collisions and interactions are common. But inside a void, galaxies are widely separated. Interactions between them are rare. The environment is quiet and relatively undisturbed. This makes voids fascinating laboratories for astronomers. By studying galaxies that live within voids, scientists can learn how galaxies evolve in isolation far from the crowded influences of clusters and filaments. Cosmic voids also continue to change over time. As the universe expands, matter continues drifting toward the denser regions of the cosmic web. This process gradually makes voids larger and emptier. In effect, the voids slowly grow as matter flows away from them. Over billions of years, neighboring voids can even merge together, creating even larger empty regions. In this way, the structure of the universe continues evolving on enormous timescales. If you could somehow travel to the center of a cosmic void, the experience would be extraordinary. The nearest galaxies might lie tens of millions of light years away. From your vantage point, the sky would appear very different from the one we see on Earth. Instead of a rich tapestry of nearby stars and galaxies, the heavens would feel distant and sparse. Most galaxies would appear as faint, isolated points far away along the edges of the void. The darkness between them would stretch across unimaginable distances. It would be one of the quietest places in the universe. Yet even in that immense emptiness, the universe would still be present. Invisible dark matter would still thread through space. Faint background radiation from the early universe would still glow softly across the cosmos. And gravity would continue shaping the slow movement of matter across billions of years. Even emptiness has its own subtle structure. So when astronomers speak of cosmic voids, they are not describing simple holes in space. They are describing the vast regions between the luminous structures of the cosmic web. Enormous cosmic bubbles, places where galaxies are few, distances are immense, and the universe becomes almost silent. These quiet regions occupy a huge portion of the cosmos. In fact, most of the universe's volume is made up of these enormous voids. The galaxies themselves occupy only the thin thread surrounding them. In the next part of our journey tonight, we will explore those threads more closely. Because the cosmic voids cannot exist alone. They are part of something even larger, the magnificent structure known as the cosmic web, where filaments of galaxies stretch across billions of light years, weaving the grand design of the universe. As we continue our quiet journey through the structure of the universe tonight, we now arrive at one of the most beautiful and astonishing ideas in modern cosmology. The universe, when seen on its largest scales, is not random. It is not a chaotic scattering of galaxies across empty space. Instead, the cosmos forms a vast and delicate structure, a structure so enormous that it stretches across billions of light years. Astronomers call it the cosmic web, and once you understand it, the universe begins to look less like a random field of galaxies and more like a magnificent cosmic network. Imagine, for a moment, a giant, three-dimensional spider web stretching across the darkness of space. Along the thin strands of that web, countless galaxies gather. At the intersections of the strands, enormous clusters of galaxies form bright cosmic hubs, and between the strands lie the vast empty bubbles we explored earlier, the cosmic voids. Together, these elements, filaments, clusters, and voids create the large-scale structure of the universe. A structure so immense that it can only be seen when astronomers map millions of galaxies across huge cosmic distances. The long strands of this network are known as cosmic filaments. Filaments are enormous rivers of galaxies. Instead of existing alone, galaxies tend to gather along these immense gravitational pathways. Each filament can stretch across hundreds of millions of light years. Along them, thousands of galaxies may drift slowly through space. From afar, a filament looks like a glowing thread woven through the darkness. But when examined more closely, it becomes a vast region containing countless galaxies, clouds of gas, and invisible dark matter. The galaxies within a filament are not stationary. They move slowly under the influence of gravity, drifting toward denser regions where clusters are forming. Where several filaments intersect, something remarkable occurs. These intersections become galaxy clusters. Clusters are the densest environments in the universe. Hundreds or even thousands of galaxies gather there, bound together by gravity. From a distance, a cluster appears like a brilliant city of stars glowing within the cosmic darkness. Within clusters, galaxies interact more frequently. Gravity pulls them toward the center. Sometimes galaxies even collide or merge with one another. Over billions of years, these clusters grow larger and more massive as matter continues flowing along the filaments into their centers. But the cosmic web is not only made of visible galaxies. Much of its structure is actually shaped by something invisible: dark matter. Dark matter does not emit light, so we cannot see it directly. Yet its gravity influences the motion of galaxies and gas across the universe. In fact, scientists believe that dark matter forms the underlying framework of the cosmic web. Long before galaxies formed, dark matter gathered into vast filaments and halos. Ordinary matter, gas, dust, and eventually stars then followed those gravitational pathways. Over time, galaxies formed along the dark matter filaments, tracing the hidden structure beneath. In this way, the cosmic web we observe today reflects the invisible architecture of dark matter across the universe. When astronomers simulate the formation of the universe using powerful supercomputers, the results are extraordinary. Starting from the tiny density variations present shortly after the Big Bang, the simulations show matter gradually gathering together under gravity. Small clumps grow larger, filaments stretch across space, clusters emerge where those filaments intersect, and between them, enormous voids open up. When these simulations are visualized, the resulting structure looks astonishingly similar to the maps of real galaxies observed by telescopes. A vast cosmic web stretching across the universe. From a distance, the cosmic web resembles something strangely organic. Some astronomers have compared it to the structure of foam or soap bubbles. Others have noticed that it resembles certain biological networks. In fact, When scientists compare maps of the cosmic web to images of neural networks in the human brain, the similarities can appear surprisingly striking. Both contain interconnected filaments and nodes, forming complex networks. Of course, the processes behind these structures are very different. Yet the resemblance reminds us that the universe often forms patterns that repeat across many scales. Within the cosmic web, matter is constantly in motion. Galaxies slowly drift along filaments toward clusters. Gas flows through the web, feeding the growth of galaxies. Meanwhile, the voids between the filaments gradually expand. Over billions of years, this slow movement reshapes the structure of the universe. Filaments become more defined, clusters grow more massive, and voids become even emptier. The cosmic web evolves slowly, but continuously. Our own galaxy is part of this enormous structure. The Milky Way resides within a filament of galaxies known as part of the Laniakea supercluster, an immense region containing thousands of galaxies. Within this supercluster, galaxies flow slowly toward massive gravitational centers. Our local region of the universe is therefore only a tiny portion of the vast cosmic web. Beyond it lie countless other filaments, clusters, and voids stretching across the observable universe. When astronomers step back and view the cosmos on the largest scales, they see something extraordinary. The universe is not just a collection of galaxies scattered randomly across space. It is a grand structure, woven from threads of matter across billions of light years, filaments of galaxies glowing softly in the darkness, clusters shining at the intersections, and between them all, the silent cosmic voids we have been exploring. The cosmic web is the universe's great design, a structure shaped by gravity, dark matter, and the slow evolution of cosmic time. And as we continue drifting through this quiet exploration tonight, we will soon move closer to some of the largest empty regions ever discovered. Because among the many voids scattered across the universe, a few stand out as truly immense. Vast cosmic cavities where galaxies are incredibly rare. In the next part of our journey, we will visit some of the largest cosmic voids known, including one of the most mysterious regions of emptiness ever found in the universe. As we continue drifting through the vast architecture of the cosmos tonight, we now arrive at some of the most extraordinary structures ever discovered. Not the largest galaxies, not the brightest clusters, but the largest, empty regions in the universe. Cosmic voids that stretch across distances so immense that they challenge our imagination. Among these enormous spaces, one void in particular captured the attention of astronomers when it was first discovered. It is known as the Bootes void, and for a time it became famous for what it lacked. Almost everything. The Bootes void lies roughly 700 million light-years away from Earth, in the direction of the constellation Bootes. When astronomers first mapped this region in the early 1980s, they noticed something remarkable. In a section of space where many galaxies should have been present, almost none appeared. The region seemed strangely empty. At first, scientists suspected that the observations might be incomplete. Perhaps the telescopes had simply not detected faint galaxies within the area. But as more data was collected, the mystery deepened. The emptiness remained, and the scale of that emptiness turned out to be astonishing. The Bootes void measures roughly 250 million light-years across. To grasp the enormity of that distance, it helps to compare it with something familiar. Our entire Milky Way galaxy is about 100,000 light-years wide. That means you could line up 2,500 Milky Way galaxies side by side and still not span the full width of the Bootes void. It is one of the largest known regions of space where galaxies are extremely rare. Inside such an immense cosmic cavity, the universe becomes almost silent. When the void was first discovered, astronomers found only a few dozen galaxies within its enormous volume. Later, observations revealed a few more scattered throughout the region. But compared with the surrounding areas of the cosmic web, the density of galaxies remains extraordinarily low. Imagine standing inside a city and looking out at thousands of glowing lights across the skyline. Now imagine traveling far into the desert, where those lights disappear and the horizon becomes empty. Cosmic voids are like those deserts of the universe, except instead of miles of emptiness, they stretch across hundreds of millions of light years. The discovery of the Boötes void raised fascinating questions. Why would such an enormous region contain so few galaxies? Did something unusual happen during the early formation of the universe? Or was this simply a natural result of the cosmic web evolving over billions of years? Over time, astronomers began to understand that the Boötes void was not an isolated oddity. It was part of a larger pattern. Many voids exist across the universe, some smaller, some even larger. Together, they form the vast, empty spaces between the filaments and clusters of the cosmic web. When scientists map the distribution of galaxies across the observable universe, they find that voids occupy a surprisingly large portion of cosmic space. In fact, most of the volume of the universe lies inside these enormous empty regions. The galaxies themselves occupy only the thin filaments and clusters along the edges. In other words, the universe is not primarily made of galaxies. It is primarily made of space between galaxies. The luminous islands of matter form only a delicate framework surrounding enormous cosmic voids. Although voids contain very little matter, they are not completely empty. A few isolated galaxies still drift through their interiors. These galaxies often live very different lives compared with galaxies inside clusters. Because they are so far from their neighbors, they experience far fewer gravitational interactions. Collisions between galaxies are rare. Mergers are uncommon. These galaxies evolve quietly, isolated in the immense stillness of the void. Astronomers sometimes refer to them as void galaxies, and studying them helps scientists understand how galaxies behave when they grow without the disturbances common in crowded regions. Voids are also constantly changing. As gravity pulls matter toward the filaments and clusters of the cosmic web, the interior of voids gradually becomes even emptier. Matter slowly flows outward toward the edges. This process causes voids to expand over time. Neighboring voids may even merge together, creating even larger empty regions across the universe. In this way, the structure of the cosmos evolves slowly, shaped by gravity across billions of years. If you could somehow travel to the center of a massive void like the Boötes void, the view would be unlike anything we experience here on Earth. The nearest galaxies might lie tens of millions of light years away. Instead of the rich cosmic neighborhoods we see in telescope images, the sky would appear sparse. A few distant galaxies might glow faintly along the far horizon of the void, but most of the sky would be dark, a quiet ocean of space stretching across unimaginable distances. Yet even in this immense emptiness, the universe continues its silent work. Gravity still shapes the motion of matter. Dark energy continues to drive the expansion of the cosmos, and faint radiation left over from the early universe still fills the background of space. Even the emptiest regions of the cosmos remain part of the universe's grand story. As we continue our peaceful journey tonight, we will soon look more closely at what life might be like for galaxies living inside these quiet regions. Because although voids may appear empty from afar, a few galaxies still inhabit them. And these isolated galaxies evolve in ways very different from those living inside crowded clusters. In the next part of our exploration, we will step into those silent environments and discover what it means for a galaxy to live inside a cosmic void. As our journey continues tonight, we now leave the crowded intersections of the cosmic web and drift into one of the quietest environments the universe can offer, the interior of a cosmic void. From a distance, these enormous regions appear almost empty. But almost is the important word, because even in the vast silence of a void, a few galaxies still exist. They drift slowly through the darkness, separated from one another by enormous distances. These are known as void galaxies, and they live very different lives compared with galaxies found inside dense clusters. To understand this difference, imagine two cities. One is crowded, vibrant, and constantly busy. People move through the streets. Buildings grow close together. Interactions happen everywhere. The other city lies far out in a quiet desert. Only a few houses stand scattered across the landscape. The streets are calm. Life moves slowly. The difference between cluster galaxies and void galaxies is somewhat similar. In crowded regions of the universe, galaxies interact frequently. Gravity pulls them together. Some galaxies collide and merge with one another. These encounters can trigger bursts of star formation or distort the shapes of galaxies entirely. Clusters are dynamic places where gravity constantly reshapes the cosmic landscape. Inside a void, however, things are very different. Galaxies living within these regions are incredibly isolated. Their nearest neighbors may lie millions of light years away. Encounters between galaxies become extremely rare. And because of this isolation, the galaxies inside voids evolve in a much quieter and slower way. They live calmer cosmic lives. Astronomers studying void galaxies have noticed several interesting characteristics. Many void galaxies appear smaller and less massive than galaxies found in dense clusters. They often contain fewer stars, and their structures can be simpler. Some are delicate spiral galaxies with thin arms winding gently around their centers. Others appear irregular, shaped by slow internal processes rather than dramatic collisions. Without frequent gravitational disturbances from nearby galaxies, these systems have more time to evolve quietly. Another intriguing feature of many void galaxies is their continued star formation. In crowded galaxy clusters, star formation sometimes slows down as galaxies lose gas through interactions with their neighbors or with the hot gas that fills the cluster environment. But in void galaxies, the situation can be different. Because they remain isolated, they often retain more of their original gas. This gas can continue collapsing into new stars over long periods of time. As a result, some void galaxies still produce young blue stars, even when many galaxies in denser environments have already slowed their stellar production. From a visual perspective, a galaxy living inside a void might experience an extraordinary night sky. If there were observers on a planet within such a galaxy, their cosmic neighborhood would appear remarkably empty. Nearby galaxies, the bright spirals and glowing clusters we see in many telescope images would be extremely distant. The nearest galaxy might lie tens of millions of light years away. In comparison, the Andromeda Galaxy, our closest large neighbor, is only about 2.5 million light years from Earth. In a cosmic void, distances between galaxies are often far greater. The sky between them would feel vast and silent. Yet despite this isolation, void galaxies are not completely disconnected from the rest of the universe. They still reside within the larger framework of the cosmic web. Gravitational forces from distant filaments and clusters still influence their motion. Over billions of years, some void galaxies may slowly drift toward the edges of the void where the cosmic web becomes denser. Eventually, they might even join the larger filaments of galaxies. But this process unfolds over enormous timescales. For now, many void galaxies continue their quiet journeys through the vast, empty interiors of these cosmic bubbles. Studying void galaxies provides astronomers with valuable insights. Because these galaxies evolve with fewer external influences, they can reveal how galaxies grow under more natural conditions. Without the frequent collisions and disturbances found in clusters, astronomers can observe how internal processes like star formation, gas dynamics, and dark matter halos shape galaxies over time. In this sense, void galaxies act like cosmic laboratories. They allow scientists to study galaxy evolution in some of the simplest environments the universe offers. Another fascinating aspect of cosmic voids is how matter flows around them. Because voids contain so little matter, gravity pulls material outward toward the surrounding filaments. Galaxies near the edges of voids gradually drift toward the denser structures of the cosmic web. This movement slowly reshapes the boundaries of the void. Over billions of years, voids can expand and change shape as matter continues migrating toward the filaments. Even emptiness participates in the slow evolution of the universe. If you could somehow travel to the center of a cosmic void and look out across the universe, the view might feel both peaceful and humbling. Instead of a crowded cosmic skyline filled with galaxies, the sky would appear mostly dark. Only a few faint galaxies might glow far away near the edges of the void. Their light would be soft and distant. Between them, the darkness of space would stretch across unimaginable distances. It would be one of the quietest places in existence. Yet even there, in that immense silence, the universe would still be alive with motion. Galaxies drifting slowly through space, gravity shaping the flow of matter, dark energy gently expanding the fabric of the cosmos. Life inside a void may appear quiet, but it remains part of the great cosmic story. And as we continue drifting through that story tonight, we will soon explore something even more intriguing. Because cosmic voids are not static regions. They are slowly changing over time, expanding, evolving, and reshaping the cosmic web itself. In the next part of our journey, we will discover how the expansion of empty space plays a surprising role in the growth of cosmic voids across the universe. As we continue drifting through the silent architecture of the universe tonight, we now arrive at a fascinating idea, one that reveals something subtle but powerful about cosmic voids. These enormous empty regions are not simply sitting still. They are growing. Slowly, quietly, but steadily. The emptiness itself is expanding. To understand why this happens, we must remember something important about the universe. The universe itself is expanding. This idea was first discovered in the early 20th century, when astronomers observed that distant galaxies are moving away from us. The farther a galaxy lies from Earth, the faster it appears to be receding. This motion is not because galaxies are flying outward from a central explosion. Instead, it is because space itself is stretching. The fabric of the universe is expanding. Galaxies are simply carried along with that expansion, like raisins drifting apart in a loaf of bread as the dough rises in the oven. But the expansion of the universe does not affect all regions of space equally. In areas where matter is dense, such as galaxy clusters, gravity works to pull matter together. Clusters of galaxies remain gravitationally bound. Even though space expands, gravity keeps these systems relatively stable. But in regions where matter is scarce, things behave differently. In cosmic voids, there is very little gravity pulling matter inward. With so little mass present, nothing strongly resists the expansion of space. As a result, the expansion of the universe can stretch these empty regions even more easily. Void interiors gradually grow larger. Imagine a cosmic bubble floating inside a vast ocean. If the surrounding matter slowly drifts away from the center, the bubble expands. This is similar to what happens inside cosmic voids. Matter slowly flows outward toward the denser filaments of the cosmic web. As this process continues, the interior of the void becomes even emptier, and the boundaries of the void gradually move outward. Over billions of years, neighboring voids can even merge together, forming larger and larger regions of emptiness. This process is sometimes described as void expansion, but it is not expansion in the sense of something pushing outward. Instead, it is more like the universe slowly redistributing its matter. Gravity pulls galaxies and dark matter toward the dense filaments and clusters. Meanwhile, the underdense regions, the voids, lose material. As the matter leaves, the void grows. It is a gentle reshaping of the cosmic web, a slow rearrangement unfolding over billions of years. Another mysterious force also plays an important role in this process, a force that scientists still do not fully understand. It is known as dark energy. Dark energy appears to be a property of space itself. It acts like a kind of cosmic pressure that pushes the universe to expand faster and faster over time. Although dark energy is invisible and difficult to detect directly, its effects can be measured through the motion of distant galaxies. Observations show that the expansion of the universe is not slowing down. It is accelerating, and dark energy appears to be the reason why. In cosmic voids, the influence of dark energy becomes especially noticeable. Because voids contain so little matter, gravity provides less resistance against the expansion driven by dark energy. This allows the emptiest regions of the universe to expand even more freely. Over immense timescales, voids become larger. Their interiors become emptier. The cosmic web gradually stretches and thins. Clusters remain connected by filaments, but the distances between them slowly increase. This means that the universe we see today is not the same universe that existed billions of years ago. In the distant past, cosmic voids were smaller, galaxies were closer together. The cosmic web was more compact, but as the universe expanded, the voids grew. They stretched outward, pushing the filaments of galaxies farther apart. Even today, this process continues. The universe is still evolving, still stretching, still rearranging its vast network of matter. If you could observe the universe over billions of years, the changes would become visible. Filaments would drift slowly apart. Clusters would grow slightly more isolated, and the cosmic voids between them would expand like enormous bubbles in the fabric of space. Eventually, the universe may become dominated by these immense empty regions. Galaxies will remain clustered together in their gravitational communities, but the spaces between them will grow ever larger. The universe will become quieter, more spacious, more silent. From a human perspective, these changes are unimaginably slow. They unfold across billions of years, yet they are happening right now. The universe around us is slowly expanding. The cosmic voids are gradually widening, and the great web of galaxies continues to evolve. So when we imagine cosmic voids tonight, those enormous silent regions between the galaxies, it is important to remember that they are not static emptiness. They are living parts of the universe's structure. They expand. They merge. They reshape the cosmic web itself. In the next part of our journey, we will explore another fascinating feature of these vast regions. Because cosmic voids are not only empty, they are also some of the coldest and quietest places in existence. Places where the energy of the universe becomes faint, and the silence of space grows deeper still. As we continue our slow journey through the vast emptiness of cosmic voids tonight, we arrive at another remarkable characteristic of these enormous regions. Cosmic voids are not only empty, they are also among the coldest and quietest places in the entire universe. Far from the crowded clusters of galaxies, far from the energetic centers of stars and black holes, the interiors of voids exist in a kind of cosmic stillness, a silence that stretches across millions of light years. To understand why voids are so quiet, we first need to consider the sources of energy in the universe. Galaxies are filled with activity. Stars burn brightly, releasing enormous amounts of light and heat. Supernova explosions send shockwaves through interstellar space. Black holes swallow matter and emit powerful jets of radiation. Even ordinary star formation creates energetic environments where gas clouds collapse and ignite. In galaxy clusters, these processes occur across thousands of galaxies at once. The result is a rich and active cosmic environment filled with light, radiation, and motion. But cosmic voids are very different. Inside these immense regions, galaxies are incredibly rare. Without galaxies, most of those energetic processes simply do not occur, and so the environment becomes far quieter. One of the most fundamental measures of cosmic temperature comes from something called the cosmic microwave background. This faint radiation fills all of space. It is the leftover glow from the early universe, created shortly after the Big Bang nearly 13.8 billion years ago. Today, this radiation has cooled dramatically as the universe expanded. Its temperature is now about 2.7 degrees above absolute zero. That means the entire universe is bathed in a faint background warmth that is only slightly above the coldest temperature possible. Even the emptiest regions of space still contain this gentle cosmic glow. But inside cosmic voids, other sources of heat and radiation become extremely scarce. Galaxies are distant, stars are rare, energetic events are uncommon. As a result, voids represent some of the least energetic environments in the cosmos. In many ways, they are the closest natural examples of true cosmic emptiness, places where matter, radiation, and energy all exist at very low levels. Another important factor influencing the quietness of voids is the absence of large gravitational disturbances. In galaxy clusters, gravity pulls galaxies together. Galaxies collide. Gas clouds interact. Dark matter halos overlap. These interactions generate motion and turbulence throughout the cluster environment. But inside voids, gravitational forces are weaker because there is less matter present. Galaxies are widely separated. Their gravitational influence rarely reaches one another. Without frequent interactions, the environment remains calm. It is a place where cosmic events unfold slowly and gently. This peaceful environment makes cosmic voids fascinating for astronomers because they allow scientists to observe the universe under extremely quiet conditions. Without the energetic noise of crowded galaxy clusters, certain subtle cosmic signals can become easier to detect. For example, astronomers sometimes study the way light from distant galaxies passes through voids. Because voids contain less matter, light can travel through them with fewer distortions. These observations help scientists learn more about the structure of the universe and the distribution of dark matter across cosmic space. Voids are also interesting when studying how temperature varies across the universe. Because matter is so sparse inside voids, the gas that does exist there tends to be extremely thin and cold. Some regions may contain only a few atoms per cubic meter. To put that into perspective, the air you breathe contains billions of atoms in a single cubic meter. Inside cosmic voids, the density of matter can be so low that space becomes almost unimaginably empty. And with so little matter present, very little heat can accumulate. If you could somehow travel through one of these regions, you would experience one of the most tranquil environments imaginable. There would be no nearby stars blazing in the sky, no bright clusters of galaxies, no dramatic explosions of stellar energy, only faint distant galaxies scattered along the far edges of the void. The darkness between them would stretch across enormous distances, a quiet cosmic ocean where light itself becomes rare. Yet even in this profound emptiness, the universe remains subtly alive. Invisible dark matter still threads through space. The faint glow of the cosmic microwave background continues to bathe the void, and the expansion of the universe gently stretches the fabric of space itself. The void is not truly nothing. It is simply very close to nothing, a place where the activity of the cosmos becomes soft and distant. For scientists, cosmic voids offer a unique window into the fundamental properties of the universe. By studying how matter behaves in these quiet regions, astronomers can test theories about gravity, dark matter, and the expansion of space. Sometimes the best way to understand the universe is not by studying its brightest objects, but by exploring its quietest places. And so, as we continue drifting through the silent interiors of cosmic voids tonight, we find ourselves surrounded by one of the most peaceful environments imaginable. Regions where the temperature is near absolute zero, where radiation is faint, where galaxies are distant, where the universe itself feels calm and still. In the next part of our journey, we will imagine something even more intriguing. What would it be like if we could actually travel into one of these enormous cosmic voids? What would the sky look like? How empty would the universe feel? And how different would that experience be from the star-filled sky we see from Earth? As our quiet exploration continues tonight, we now arrive at a question that invites the imagination to wander far beyond the limits of our present technology. What would it be like to enter a cosmic void? Could we ever travel into one of these vast empty regions between the galaxies? And if we could, what would we see? At the moment, the idea of traveling to a cosmic void belongs firmly in the realm of imagination. The distances involved are enormous. Even reaching our nearest neighbouring galaxy, Andromeda, would require travelling about 2.5 million light-years. With the fastest spacecraft humanity has ever built, such a journey would take tens of billions of years. That is longer than the current age of the universe itself. Intergalactic travel remains far beyond our present capabilities, yet thinking about it can reveal something profound about the scale of the cosmos. Imagine that sometime in the distant future, a civilization develops the ability to travel between galaxies. A spacecraft leaves the familiar spiral arms of the Milky Way and begins a journey into intergalactic space. At first, the sky might still appear rich with galaxies. The Milky Way would glow behind the travelers like a vast river of stars stretching across the darkness. Ahead of them, the Andromeda galaxy might slowly grow brighter as they approach. But as the journey continues farther from these galactic islands, something remarkable would begin to happen. The sky would slowly grow emptier. Galaxies would begin to disappear from view, not because they ceased to exist, but because the distances between them are so enormous. The light from distant galaxies would grow fainter. Some would shrink to tiny smudges of light barely visible against the darkness. Others would fade completely beyond the reach of the human eye. The travelers would gradually enter one of the most isolated environments in existence, the interior of a cosmic void. Inside such a region, the nearest galaxy might lie tens of millions of light-years away. For comparison, our nearest large galaxy is only a few million light-years distant. But inside a void, the cosmic neighborhood becomes dramatically emptier. The sky might contain only a handful of faint galaxies scattered across the darkness. Between them would stretch enormous regions where no bright objects appear at all. It would feel as though the travelers had entered a vast cosmic ocean where the islands of light lie far beyond the horizon. From such a vantage point, the universe would appear profoundly quiet. On Earth, the night sky feels rich with stars. Thousands sparkle above us. But inside a cosmic void, the sky could appear almost empty. The distant galaxies would glow faintly along the edges of the void, like tiny lanterns placed far across an enormous plain. Between them would be deep, uninterrupted darkness, perhaps darker than any sky humans have ever seen. Even the Milky Way, if it were visible from that distance, might appear as only a faint, distant glow, a soft spiral of light drifting at the edge of perception. The familiar constellations we see from Earth would vanish entirely. Instead of patterns of nearby stars, the travelers would see only the faint outlines of distant galaxies, each one representing billions of stars gathered together in a faraway island of light. The sense of scale inside a void would be overwhelming. In most regions of the universe, galaxies are connected through filaments of the cosmic web. But inside a void, those filaments lie far away. The travelers would find themselves surrounded by a region where the density of matter is extremely low. The nearest gravitational influences might lie millions of light years away. For long stretches of their journey, the spacecraft might pass through space where almost nothing exists nearby at all. No stars, no nebulae, no galaxy clusters, just the thin background glow of the universe itself. And yet, even within this deep cosmic silence, the universe would still whisper its presence. The faint radiation of the cosmic microwave background would still fill space. This ancient light from the early universe would glow softly across every direction of the sky, invisible to human eyes, but detectable by sensitive instruments. It would serve as a reminder that even in the quietest corners of the cosmos, the history of the universe still surrounds us. There would also be subtle gravitational influences. Invisible dark matter might still drift through the void. Occasionally, the travelers might encounter a lonely galaxy, moving slowly through the emptiness. These rare void galaxies would appear as isolated islands of stars, drifting quietly through enormous cosmic distances. Seeing such a galaxy after traveling through millions of light years of darkness would feel like discovering a distant lighthouse in a vast ocean. But perhaps the most striking experience would be the silence of structure. In most parts of the universe, galaxies gather into clusters and filaments. Gravity pulls matter into vast networks. Inside a void, that structure fades away. The cosmic web lies far beyond the horizon. The universe becomes smooth, open, and still, a place where distances stretch almost beyond comprehension. Such a journey would remind us how unusual our own cosmic environment truly is. We live inside a galaxy filled with stars. Our galaxy sits within a filament surrounded by other galaxies, and those galaxies form part of the enormous cosmic web. But most of the universe's volume is not like this. Most of it lies inside the quiet regions we have been exploring tonight, the cosmic voids. And so, even though humanity may never travel into the center of one of these vast empty spaces, imagining the journey helps us understand the scale of the universe. It reveals just how large the cosmos truly is, how far apart its islands of light can drift, and how profound the silence of space can become. In the final part of our journey tonight, we will look far into the future of the universe itself. Because as cosmic voids continue to expand over billions of years, they may eventually dominate the structure of the cosmos. Galaxies will drift farther apart. The cosmic web will stretch thinner, and the universe may gradually become an even quieter place. As our journey through the quiet regions of the cosmos gently approaches its final stretch tonight, we turn our attention far into the future. Not thousands of years from now, not even millions, but billions, trillions, and perhaps far longer into the distant future of the universe. Because cosmic voids are not just features of the universe today, they may play an even greater role in the universe of tomorrow. Over the vast timescales of cosmic evolution, the universe continues to change. Galaxies slowly move through the cosmic web. Gravity pulls matter toward dense clusters, and at the same time, the expansion of space gradually pushes galaxies farther apart. These two forces, gravity and cosmic expansion, shape the long-term future of the universe. Inside galaxy clusters, gravity keeps galaxies bound together. But beyond those clusters, expansion slowly stretches the distances between galaxies. And inside cosmic voids, where gravity is weakest, that expansion becomes especially noticeable. As billions of years pass, the voids will grow larger. Matter will continue flowing toward the filaments and clusters of the cosmic web. Meanwhile, the interior of voids will become even emptier. Galaxies near the edges may slowly drift toward the surrounding filaments. Some voids will merge together with neighboring voids, forming even larger cosmic cavities. The cosmic web itself will stretch and thin as the universe expands. What we see today as enormous voids may eventually grow into regions far larger still. Imagine the universe as a vast network of bubbles. Over time, those bubbles slowly expand. The walls between them stretch. The empty interiors grow larger. Something similar happens on the scale of the cosmos. The filaments of galaxies remain like thin strands stretched across the expanding universe. But the spaces between them grow wider. Gradually, the galaxies become more isolated from one another. This process is driven largely by dark energy. Dark energy appears to act like a kind of repulsive pressure built into the fabric of space itself. Instead of pulling objects together, it pushes space to expand faster and faster. Astronomers discovered this surprising acceleration in the late 1990s while observing distant supernova explosions. Since then, dark energy has become one of the most important mysteries in cosmology, and it may shape the ultimate fate of the universe. As dark energy continues driving the expansion of space, galaxies outside our local gravitational neighborhood will gradually drift beyond our cosmic horizon. Their light will stretch and fade as the distances between galaxies grow larger. Eventually, galaxies that are currently visible through telescopes may disappear from view entirely. They will move so far away that their light will no longer reach us. In the distant future, observers in the Milky Way, or whatever remains of it, may see a far emptier universe. Within our own local region of space, gravity will continue to hold certain galaxies together. The Milky Way and the Andromeda Galaxy, for example, are already moving toward one another. In about 4 billion years, they will likely merge into a single large galaxy. Other nearby galaxies in the local group may also join this cosmic union. Together they will form a new, larger galaxy drifting through the expanding universe. But beyond that local group, most other galaxies will slowly disappear into the expanding darkness. As the universe ages further over trillions of years, the cosmic web will become increasingly stretched. Clusters will remain gravitationally bound islands of galaxies. But between them, the cosmic voids will dominate. The distances between galaxy clusters will grow larger and larger. The universe will become quieter, darker, more spacious. Cosmic voids will occupy an even greater fraction of the universe's volume. If intelligent observers exist in such a distant future, their view of the cosmos may be dramatically different from ours. From their vantage point, the universe might appear almost empty. Only their local cluster of galaxies would remain visible. The rest of the cosmic web would lie far beyond their observable horizon. They might not even know that billions of other galaxies once existed. The universe would appear small, quiet, and isolated. The memory of the vast cosmic network we see today would be hidden by the expansion of space. Yet even then, the universe would continue evolving. Stars would slowly burn through their fuel. Galaxies would change shape as stellar populations age. Black holes would continue consuming matter, and the enormous voids between clusters would keep expanding silently. The cosmos would become a quieter place with each passing epoch. But tonight, as we reflect on these distant futures, we can also appreciate the extraordinary moment in cosmic history that we inhabit. We live at a time when the universe is still rich with visible galaxies. The cosmic web remains clearly observable. Clusters, filaments, and voids are all part of the grand structure we can explore with telescopes and imagination. The universe has not yet faded into the long, quiet era that may one day arrive. And so as our journey through cosmic voids comes to an end, we are left with a sense of wonder. The universe is both crowded and empty, filled with galaxies, yet dominated by vast regions of space where almost nothing exists. The cosmic voids remind us that emptiness itself plays a crucial role in shaping the universe. The silent spaces between the islands of light, the vast oceans between the galaxies, places where the universe grows quiet and the scale of the cosmos becomes almost impossible to imagine. Soon, we will drift gently into the final reflection of tonight's journey, one last peaceful moment among the quietest regions of the universe before we rest beneath the stars. As our quiet journey through the vast structure of the universe slowly comes to an end tonight, it is comforting to pause and reflect on what we have discovered together. When we look up at the night sky from Earth, the universe appears full. Stars sparkle above us. The Milky Way stretches across the heavens like a glowing river of light. Through telescopes, we see distant galaxies, nebulae, and clusters of stars filling the cosmos with brilliance. But when we step back and look at the universe on its largest scales, something surprising becomes clear. Most of the universe is empty. The galaxies that shine so brightly are only small islands scattered across an enormous cosmic ocean. Between those islands lie the vast regions we explored tonight. The cosmic voids, enormous stretches of space where galaxies are rare and the universe grows quiet. In these immense regions, distances become almost unimaginable. Galaxies may lie tens of millions of light years apart. The sky grows darker. The familiar patterns of stars fade away, and the universe reveals just how vast it truly is. Yet even in that great emptiness, the universe remains alive. Gravity continues its slow work. Dark energy stretches the fabric of space, and faint ancient radiation from the early universe still glows softly across the cosmos. The void is not truly nothing. It is simply the quiet background against which the great structures of the universe are written. In a way, the cosmic voids remind us of something simple and beautiful, that the universe is not only defined by what exists within it, but also by the spaces between. Just as music needs silence between its notes, the cosmos needs emptiness between its galaxies. Those quiet spaces allow the cosmic web to take shape. They give the universe its grand structure. They provide the calm background against which the islands of light can shine. So tonight, as you allow your mind to drift towards sleep, imagine yourself floating gently through one of those vast cosmic oceans, far from crowded clusters of galaxies, far from the bright glow of stars, just drifting peacefully through the quiet depths of space. Around you, the universe stretches endlessly in every direction. A few distant galaxies glow softly along the far horizon, but most of the sky is calm and dark, a peaceful cosmic silence. Let that quietness settle around your thoughts. Let the vastness of the universe feel gentle rather than overwhelming, because within that immense emptiness lies a kind of calm that few places in existence can offer. The calm of deep space, the calm of the cosmic voids. Now it's time to rest. Allow your breathing to slow. Let your thoughts drift softly like galaxies moving through the quiet universe. And as the ambient music begins to play, imagine yourself continuing this peaceful journey through the great emptiness of space. Good night, sleep well, and may your dreams drift gently among the silent cosmic voids.